So Azure uses system routes as well as user-defined routes to direct traffic between virtual machines in the same subnet or different subnets, same virtual network, data flow from VMs to the internet, site-to-site communication, express route communication through a gateway. All of those, it uses system routes, but we have the ability to create user-defined routes to control network traffic. These user-defined routes are very similar to just routing table entries that we would configure in an on-prem environment that specify the next hop for a particular location. These are available at no charge. You're not going to necessarily need them, but if you do require the ability to control how things are routed, then you can use user-defined routes to do that. In order to utilize user-defined routes, you need to create routing tables, and those routing tables will have custom routes within them, and then we'll just associate the routing table with the appropriate subnets. Okay, so when you create a routing table, you do things like give it a name, choose a resource group, choose a location, the standard stuff. But the one thing that we would do, one option is VNet gateway propagation, and this is actually, it's just kind of a toggle that you enable or disable. Well, what it means is that routes are automatically added to the route table for all subnets where this is enabled. If you're using express route, propagation makes sure all subnets get the routing information. It's sort of like a dynamic route. You're adding a static route. Do you actually want to propagate to all subnets that use the same VPN gateway in the instance that you have multiples? If you do, then we choose that option. Once the routing table is created, we would then create a custom route. We just give it a name and specify the private subnet, and then we specify the next hop. And it could be a virtual network gateway, it could be the internet, it could be a virtual appliance. It doesn't matter. You're just specifying an object where we are going to send this traffic. And then the final step is just to associate the routing table with a particular subnet. And when you go to look at the subnets, you will see, or when we created a subnet, we noticed that there was a route table down at the bottom. We didn't really discuss it, but that's where you would go. And you can assign a route table to multiple subnets, and each subnet can have more than one route table assigned to it. As we've mentioned, routing tables give us the ability to control the route that traffic would take. In multi-subnet environments, in environments that include on-prem and Azure VNets, this could be required. So we're not going to go through some extreme examples or anything. I just want to show you how to go about doing that. So you can literally just type in routing, or actually route, excuse me, and you'll see route tables in the list. At that point, you just create your own route table. Now, a route table is just a collection of individual routes. We can create a resource group for it. We're just going to put it in that same one. I realized, going back to the resource groups, you can create resource groups for different sets of objects. It's just sometimes there's some complexities moving between resource groups. Sometimes there are some complexities if they're in, physically different regions. And so it's a good idea, I think, to collect like resources into the same group. All right. Now, I'm not necessarily doing that. Like, you could have a firewall and NSG resource group. You could have the VNet gateway and all the resources corresponding to that in its own resource group. That probably makes more sense from a production environment. In my case, I'm really just trying to combine everything into a resource group that I can eliminate so that we don't have to pay for it. All right. All right. The route table, the region, it does not default. In this case, it doesn't necessarily matter that it's in the same region. The name, so we'll just say PL route table. And do we want to propagate gateway routes as we had discussed? The functionality of that, yes or no, and just the ability to share a gateway with multiple networks. So we're going to say no or yes, and hit review and create. Validation passed, we submit the deployment. As with all other resources, we sit and wait, although the route table should be fairly quick. There we go. So we're going to go to that resource. So under settings, that's where you're predominantly going to be doing things. If you want to change the propagation of gateway routes, you can do that. Obviously, this is a table, but it actually has no routes. Okay. My test route. So we're just going to specify the address prefix. This is where we want to go. So I'm going to say if you're going to the 172.16.2.0/24 network, then the next hop should be either virtual network gateway, virtual appliance, whatnot. So I'm going to say the virtual appliance, and then we would specify the address. So this is just really defining the type that it is. It probably could work, although I haven't tested this out. Probably could work even if you didn't correctly identify it. But in my case, it's a virtual appliance. It could be a virtual network gateway, an actual VNet, the internet. In our case, I want to route it to the firewall. So 172.16.3.1. All right. And hit OK. Now, to be quite honest, I don't know if that was the IP address of the router or of the firewall or not. Again, we're not going to do some long-running setup for this, just because this is fairly uncommon unless you're in the multi-network environments where you really need to control traffic. And when I say multi-network, I'm not just talking two. Two is normal. 2 or 3 within Azure, 2 or 3 subnets, that's normal and wouldn't really require route tables. The idea here is if you want to route like completely separate VNets through for instance, a firewall, which is kind of what I'm simulating here. You can click on subnets and you can associate the route table with particular subnets now. So I would associate this with my PL test VNet. Okay, that's where and the default subnet is the one I'm going to choose because that was the route. And I said basically, if you want to communicate with the 2 network, these are peered. If you want to communicate with the 2 network, you need to go and communicate with this firewall. At which point I really need to go back and I need to peer the virtual networks that I had existing, VNet 1, VNet 2, with that firewall virtual network. But the concept here is really straightforward. Most of us probably have some background in networking, so we know what a route table is, we know what a route table entry is, and we know that if you don't have it, you're going to just send to your default gateway. So in Azure, if we need to route traffic differently, we can create our own route tables and populate them with routes and then associate them with certain subnets. Other ways we can control the traffic flow is through load balancers. Load balancers provide high availability and increased performance for application, and they do so by distributing inbound traffic as well as bypassing failed nodes. So load balancing in general is just going to take incoming network traffic and pass it to multiple back-end systems in a particular order, right? And then if one of those systems is down, then that system can be bypassed. So clients or other servers are only accessing the public IP address of the load balancer, and they are not actually accessing the internal devices. Okay, now there are the primary components, I guess we should say, of the load balancer are going to be your front-end IP configuration. Okay, the back-end pools of systems. We'll have load balancing rules that determine which ports are going to be load balanced and the actual method of load balancing. And then we'll have health probes that are used to determine if those back-end systems are actually up and running. Okay, so those are all the components that we would have to create and then configure in order to implement this. But if you've ever done anything with load balancing, this is actually pretty similar to any hardware load balancers that would be out there. We've also got a couple different types. You've got the public load balancer, which maps a public IP address and port number to the private IP address and port of a VPN. Okay, so a public load balancer is available on a public IP and is used, for instance, to balance incoming web requests. An internal load balancer is a bit different. It directs traffic to resources that are inside the virtual network or that use a VPN. So the front-end IP address and the virtual network on an internal load balancer would never actually be exposed to the internet. Okay, so you can do load balancing from VMs in a virtual network to another set of VMs within the same virtual network, or you can do it across virtual networks. You know, a lot of times these are used for multi-tier applications. Okay, so we would have maybe a public load balancer for the first tier, that web tier, but then you have intermediary and back-end tiers. They require load balancing from the internet-facing tier, but they are probably not publicly accessible. Okay. And then we've got SKUs. So you've got the basic SKU versus the standard SKU. Those are kind of the big one, or those are the only two. The basic SKU lets you have up to 300 systems in the back-end pool, whereas standard gives you up to 1,000. The health probes are a bit different. Standard includes HTTPS along with HTTP and TCP, and the basic does not. Basic doesn't support availability zones, and basic is not secured by default, although you can put NSGs on there. There is no SLA for the basic SKU, but standard SKU is a 99.99% service level agreement. So again, some of that you could just kind of know in planning. Some of that's a little bit just kind of understanding some capabilities for the purposes of the exam. In addition to some of the other network components that we've talked about, we have just been discussing the Azure Load Balancer. And in this demonstration, we're going to go through just some basic configuration for the load balancer. We know the functionality here is to increase performance and increase availability by eliminating potentially, smaller, less used host or unused host, by eliminating from a scalability perspective, by eliminating hosts that are down and unavailable from an availability perspective. Okay, so we see what's going on here. Now, interestingly enough, and this is a help me choose, you can see it's in preview, but it's identifying the fact that we actually have multiple load balancing services here. The load balancer is one of them. We will be talking about the application gateway and mentioning traffic manager as well. Okay, so it just kind of depends on what you want to do. And it's trying to help you choose by showing you that all four are related. Now, I'm just going to go with load balancing, and I'm going to click New. This is basically, I've already decided it. Why do they have these all here? Well, because you can click on each individually, and then you can get access to documentation. They're just wanting you to know the others exist. All right, so the resource group is going to be our PL Test resource group. My load balancer, East US region, and then we've got the types and the SKUs. Okay, so the type, is it internal versus public? In this case, it's going to be public. The SKU, you can see that's recommended for production. And then the tier that we're going to use, we're using a regional tier, not a global tier. I need to create a public address. And then I need to determine if I'm in an availability zone or not. Now, most of the time we would probably do, zone redundant. But in our case, I'm not going to do that. I don't need to add a public IP address. And then I've got my routing preference, which we're going to choose internet. Okay, it'll go through the validation. We'll go ahead and create the load balancer, and it initializes that deployment. Okay, already finished, so we're going to click Go to Resource. Okay, and then under Settings, we can see the basic configuration. Okay, so your front-end IP configuration. This is my address that was generated for me. So that's the public, you see my load balancer IP. That's the public IP address. You can add additional IP addresses if you want. Then we would be specifying the back-end pool. What do we think we are, what are we creating right now? I mean, we're basically just creating a pool of systems, okay? So notice it's, when I choose PL Test 1, then I'm saying the configuration by NIC or by IP address, the IP version, and then it is going to prompt me for virtual machines, okay? So And in this case, it is saying nothing's been found that matched the criteria. All right, I'm going to go with IP. I don't believe that's going to change. It might. We can plug in individual addresses. And I'm trying to remember what it was, 0.4 maybe. Okay, and I can choose, the resource name and whatnot, and try to add those in there, and it will attempt to validate and access that. Now, I haven't created the VMs that are going to be on the back end, but okay, it actually did with Windows 10 anyway, because from the load balancer's perspective, it's basically just does it exist. So if I had another Windows 10, I do, but they're in different subnets. In the same subnet, we could go ahead and add those. You've got your health probes, and you can add those checking for a particular application. We've got, probably more importantly, load balancing rules, in which we create a rule. It's an IPv4 or IPv6. We choose the front end address. We choose the protocol. We choose the port number. And then we choose the back end pool. Okay. Now, obviously, we must have added virtual machines to that pool. And then I'll either choose a health probe or create a new one. So you can have already previously created them, or you can just create it here. So we'll go to HTTPS probe. And the protocol is HTTPS, and therefore the port is 443. But notice I've also got the ability to choose that. Just go away. That accidentally disappeared on me, it looks like. Oh, no, there we go. We'll say OK. The health probe was looking at the number of failures and whatnot there. We can do session persistence if that's required. We can configure idle timeouts, resets, and other things, and then we can just add. Okay, so the rule is just mapping from the front-end IP configuration to the back-end pool. The health probes are looking for specific ports or can be told to look for specific destinations in the URL. Notice we have inbound NAT rules, outbound rules as well, a number of other settings. Okay, so basically you get the VM set up, you get the virtual network set up, hopefully your Azure firewall, and then behind the Azure firewall there would be a load balancer. Okay. So on the firewall, we would also need to configure rules to allow access into the load balancer, presumably. And then you can start to see the benefit of using that load balancer, both from a performance and efficiency standpoint, as well as from an availability standpoint.